Okay, so for today onwards, we are going to start with our A2 syllabus. Alright, so we are still having 3 more weeks to go before your semester exam. Semester break. Alright, then for these coming 3 weeks, we are going to focus on paper 3 only. Alright, so our chapter 1, which is Algebra for A2 syllabus. Alright, so again, for A2 syllabus, most of the math topics, it actually involves some new things that you never learned before. Therefore, it will be a bit different from what you did in AS. In AS, maybe after every single lesson, you know how to do the example, then you can straight away proceed with the final, the exam paper, the past year paper, right? But for A2 syllabus, it is a bit different. After every single lesson, if can, you actually need to try and do some basic exercises first before you can proceed to the past year question. Alright, because some past year question actually is quite complicated and quite challenging. Alright, so if let's say your basic is not good, then generally it's quite hard for you to complete the past year question. Alright, so this is what I suggest. If let's say you can try to complete some very basic exercises first, right, before you proceed to the past year. Okay, so for this one, we are going to have chapter 1 here. Chapter 1, we are talking about algebra. Alright, so for this chapter 1, it is actually quite long because it consists of 4 parts. So the first part is modulus function. Okay, and then for the second, we are having polynomial. Okay, then for third part, we have partial fractions. And the fourth part is binomial expansion. Alright, so for these 3 weeks, we are going to cover these 4 subtopics here. Alright, so again, I'm not going to teach very fast. So like every single lesson, right, after you completed the example and also the video, then you can try to do or complete the exercises, the simple one first. And then after that, only you proceed to the past year. Okay, so these are the 4 weeks we have in this chapter 1. Okay, so let's start with our very first part, the modulus function. Okay, so for this modulus function, for this chapter, this subtopic, the learning outcome is what? The learning outcome is you need to know some basic concept or meanings of the modulus x. And also, you need to know that when we are having a square equals to b square, and you take square root both sides, right? They should be written as square root a, modulus a equals to modulus b. Okay, and also you need to know how to expand modulus x minus a smaller than b and expand it become the equation or inequality without modulus sign. So all these are something important. Okay, and after that, you also need to understand the meaning of modulus x, and also you need to sketch the graph of y equals to ax plus b. Okay, so for this particular video for today, we are going to focus on this one, how to sketch the graph, and also what is the meaning of modulus x, and how we use all these concepts to answer the question. Now we are going to cover it maybe in the next video, right? Okay, so let's start with some very basic idea first about the modulus x. Okay, so for when you're having any function, no matter what kind of function you have, if let's say I put the modulus outside, okay, so like last time, you know that when I put modulus negative 2, that means you are going to change it become 2, right? The negative value, you need to change it become positive. All right, so last time we are talking about the numbers. Okay, but for now we are going to talk about the function. So the function means that, let's say I'm having modulus x. What is the meaning behind modulus x? And what will happen if we are having modulus x here? Okay, all right, so as what you learned before, if you're having a negative value, when you put the modulus, you're going to change it become a positive value. So the same thing happened here. When you're having a function, okay, and if your function is negative, when you put the modulus to the function, you need to reflect the negative graph, the negative part become positive. And then the positive is not changed, will not be changed, okay? All right, so generally the very basic idea is still the same. That means the negative value, you need to change it become positive. This is what you learned last time. And then now when you are having modulus a function, then you need to change the negative part of the function and you reflect it become positive. So that's the meaning of a modulus sign or modulus function. Okay, so the details I will tell you later by using some example for more for further understanding. Okay, and then the next one, for any curve of the form y equals to modulus fx, okay, it can be written as non-modulus form. So all the modulus function, you can write it become a pattern, okay, or the function or the equation with non-modulus form, that means without modulus one. You can actually split a modulus function, okay, become two. One part is fx, another part is negative fx with a certain domain. Okay, so this one we call as non-modulus form. And this non-modulus form actually in some of the question is very important, so you need to know. Alright, so in short, for this particular part, you need to know two things. The first one is you need to know how to draw or how to write out the modulus function into a non-modulus form. And another one is you need to learn how to sketch the graph for a modulus. Okay, so how to sketch a graph is also very important. These two concepts are linked with each other. All right, so therefore you need to know actually what's the meaning of non-modulus form and also what's the meaning of modulus x. Okay, so by using this particular example, I will want to explain in a very simple way. Okay, so how can I draw the graph for modulus x and how can I write out in a non-modulus form? Okay or not? So let's say now, from the beginning, I have y equals to modulus x. Okay, how can I sketch the graph for y equals to modulus x? So at first, if you want to sketch this graph, what you need to do is you need to assume that there's no modulus first. Okay, so how can you sketch the line or the equation y equals x? So I think this one everyone can draw, right? Okay, so y equals to x, your graph will look something like this. Okay, your graph will look something like this. This is y equals to x, and that also you're having this. This is also y equals to x. Okay, all right. So now, if I put a modulus sign here, what will happen? So this is originally y equals to x, right? If I put a modulus x to the function, what I need to do is I actually need to change the negative part become positive. So where's the negative part of this original graph? So the negative value is this one, right? Any graph which is below the x-axis, so this is green color part is the negative part, and what you need to do is you need to reflect it up. So it will become something like this. Okay? Alright, so if let's say you want to compare, maybe I draw a dotted line here. So this is the original graph for green color, and this green color part is negative. Therefore, when I put a modulus sign, I need to reflect green color part up to the positive part. So this whole graph here, the V shape here, can you see a V shape here? It is actually the y equals to modulus x. Okay, if let's say you didn't reflect this whole line, is y equals to x. Okay, so when you put a modulus, that means that you are changing the negative part become positive graph. Yeah, and usually for your modulus function, for linear function, modulus linear function, it will look like a V shape. Okay, and then you need to see that, you need to know that, okay, the value here is a 0, right? Okay, all right, so this is the graph that we have, and then you also need to know that original graph is y equals to x. When you reflect the graph from the bottom go up, right, the equation is actually y equals to negative x. So this is a green color part. When you reflect the graph, because when you do the reflection, right, you put a negative outside, correct or not? We learned the translation before. When you put the negative outside, that means what? That means that you're reflecting the graph through the x-axis. Okay, so now you're reflecting the graph through the x-axis. So originally it is y equals to x. So when you reflect it up, it becomes y equals to negative x. Okay, and the red color part, it is still remain as y equals to x. It is still the original function because you didn't reflect it. Okay, so you'll see that after you reflect your graph, you are having two parts of graph here. One part is green color, one part is red color. Green color one is the reflected one, red color is the original one. Alright, and then for the reflected part, you need to put the negative in front. So the original one, you keep it as the original function without modulus. Okay, so that means from these two, if you combine these two functions together, you can write it out in the non-modulus form. So that means you're having x, you're having negative x. Okay, so for the x, what is the x here? What's the domain here? So y equals to x means that you didn't reflect it. Which part you didn't reflect? This part, right? What's the domain for this part from here onward? So for this part is x greater equals to 0. So you can put x greater equals to 0 here. And for the reflected part, it is on the left hand side, this one. Right now, so it is for x smaller than 0. So you can have a look here. This is actually the non-modulus form. Okay, so this is actually the non-modulus form for y equals to modulus x. So it looks like a V shape for the modulus graph. All right, and then you need to know how to write out correctly in a non-modulus form. So for non-modulus form, usually you have one original function, y equals to x. Another one is with the negative in front. Okay, all right. So please take note on the sign here. When you put the domain, this one is x greater equals to 0, right? Then here shouldn't have equal sign. The equal sign can appear only at one side for one value. So 0, if I say the equal sign put in here, then the bottom one has no 0, no equal sign. Okay? Or it's not wrong also if you want to write it like this. X smaller than 0 and then x greater equals to 0. This is not wrong as well. Okay, alright. So again, this is what we have for the non-modulus form. And then this is what you have for the modulus graph. Alright, so how we link them together, generally they are linked with each other, right? Okay. Okay, so for this video we'll stop here, and then for next video only we are going to discuss the example in our notes. Right?